The eighth question is a tad bit tricky. I will first highlight all the information that is given to us in the question. So, first they've mentioned a dodecagon. So, a dodecagon is basically a 12-sided regular polygon. So, you might have heard of pentagon, hexagon, octagon. So, basically, in that line, a dodecagon is basically a 12-sided polygon. And they've also mentioned that it is a regular dodecagon, which means basically all the sides are equal. So, if you see here, at one point they mentioned the side as D, right? Which means all these other sides are D as well. This is D here, this is D here, this is D here, and so on, right? Moving further, they've also mentioned that it is inscribed in a circle of radius r, which means this is r, this is r, this is r, and so on. And yeah, the side of the dodecagon is d centimeters. All the triangles are used to form a square of side r centimeter, and each number triangle is used only once to form a square. And they're asking us the number of squares that can be formed and the number of triangles required to form each square. Okay, so first we'll focus on the figure. In this figure, let me clear all this up. So we'll first look at the types of triangles that are there. So these two, and these two are of the same type, right? And one, okay, let me use a different color. 1, 7, and 4 are of one type. And finally, 10, 12, and 11 are of another type. Now, if we look at the blue type of triangles, that is 2, 3, 5, 6, and 8, 9, we know this, right? This side we know it's R. This is also R. This is also R. And we know that this is D because this is the side of the dodecagon. So it has to be D centimeters, right? So for the blue type of triangles, we know all the sides. It is obvious from the figure. Now if we see the red type of triangles, similarly again this is R, this is R, but we don't know what this side is basically, right? Because if we even look at triangle number 10 or the green triangles, these two sides we know as D because they are the sides of the decagon, but again we don't know what this side is, right? So in order to figure that out, you have to use the property of the regular dodecagon. So let me once again clear everything up. And let's draw a line through the center here. Okay. So let's consider triangle number 1, right? Since you see here, it is passing through the point, one of the vertices of the triangle. So this sort of divides it into two parts. If you consider this triangle 1, you get two equal angles here, right? Because this is the side of the dodecagon and these are the two vertices. So what is the value of this angle or this angle, say? So for that, what do we have to do? Since this is a dodecagon, you divide 360 by 12. So you get 12 3 is 36 and 0. So this is 30 degrees, right? And the overall angle here is 60 degrees. Now we also know that these two sides are equal. For triangle 1, these two sides are of length r, which means through the property of triangles, where if two sides are equal, these angles must also be equal, right? So, and we know that this overall angle is 60 degrees, that we just figured out. So again, using properties of triangles, we can say that 2x plus 60 equals 180, because the internal angles of a triangle must add up to 180, which means 2x is equal to 120 and x equals 60, right? So these two sides are these two angles are 60 as well, which means it's an equilateral triangle, right? Since all three angles are the same, which means all sides are the same. Now we know that this is, let me clear everything up again. Yeah, now we know that this side is R. This basically, this is R, right? So for all the types of triangles, we now know what the sides are, what lengths they are, I mean. So now I have drawn a square here. So let's see how we can construct a square from these triangles. Now, if you see, we have to use this triangle somehow, right? Triangle number 10 or 12, basically this type of triangle. So this is of one of the sides is of length r. So let's say you have to put the r side facing outwards, because the side of the square is also r. So let's put it this way. This is r, right? And this will be d, this will be d again. And say this is the vertex. Now if you see, for the next option, basically you have to go with a triangle that has a side d. Now all the other triangles, say of this type, say 1, 4 and 7, they don't have any side that is d, so we can't consider them. And 12 and 11, again, they are of the same type as 10 of what we used, so let's not use that. And we are left with 2, 3, 8, 9 and 6, 5, these type of triangles, right? So, and we can use that because one of their sides is d. So let me once again go back to that diagram. This is what it will come like, right? So this will be d, sorry, r, this is r, this is r, and this is r. So we have covered up this entire part basically. So this side as well as this side, we have covered up the square. Now it is convenient for us because we are left with this part, and we know that this side should also be r, because this is the side of the square. And we are also left with the type of the triangle where all three sides are r, right? For 1, 4 and 7. So that will be it. So we finally covered this part as well, and the whole square is made properly. So now if you see, say we have say we have made the square using 1, 2, 3 and 10, right? So these 4 triangles we need to make the square. And we have also answered a part of the question. So the number of triangles required to form each square is 4. Alright, and let's see the number of squares. So we have covered 1, 2, 3 and 10. So all of these go. Let me do it one by one. We can also make it using 4, 5, 6 and 11. So these go as well. So that is 1 overall, 2 overall, and it will be 3, right? Because these 4 will form another square. Which means the number of squares that can be formed is 3 and the number of triangles required per square is 4. So the answer is A, 3, 4.